Key point number 2 is about the absorption and utilization of nutrients. In key point number 1, we reviewed digestion and the digestive system as a whole. Now we'll take it a step further and talk about how we absorb those nutrients. Again, in the small intestine, the carbohydrate, protein, and fat are broken down to their basic building blocks before being absorbed. So for example, carbohydrate is broken from long chains of glucose into either single units or double units called mono or disaccharides before they are absorbed. Vitamins, minerals, and water are mostly absorbed as is, meaning that as we take it into our body, so it is also absorbed. We don't do any digesting or breaking down. Fiber remains also intact in the GI tract. It is not absorbed at all, and that by definition is how we identify fiber in a food. The definition of absorption is that nutrients are taken into the intestinal cells after being broken down by digestion. In the small intestine, we have something called villi. These are finger-like projections that line the intestinal tract. And each of those villi recognize and regulate nutrient absorption. Each villi has a supply of blood vessels and also a lymph vessel. And there's a nice picture in your book that displays this. Those are available so that when we absorb nutrients, they can take the appropriate path. Microvilli sit on top of the finger-like projections. Microvilli are tiny hair-like projections that, again, they increase the surface area. So we have 21 feet of small intestine that we then add these villi, thousands and hundreds of them, throughout the GI tract. And then on top of that, microvilli. So we have a huge amount of surface area to be able to absorb nutrients through. Those hair-like projections, the microvilli, are constantly moving to increase, again, the amount of contact they might give with a particular nutrient and increase the likelihood of absorbing the maximum amount of nutrients. We have two categories of nutrients, and based on what category the nutrient falls in, that affects how it is absorbed into our system. First, we'll talk about water-soluble nutrients. Those are absorbed into the bloodstream or the vascular system. The nutrients that fall in this category are things like carbohydrate, protein, vitamin C and the B vitamins, the minerals, and then some of the small particles of fats. Most of the fats in our diet don't fit in this category, but there are a few small fat particles that would be absorbed directly into the vascular system. The next category would be the fat-soluble nutrients. These are absorbed into the lymphatic system. Nutrients that fall in this category are the larger fats, the majority of fats in our diet, cholesterol, the phospholipids, and the fat-soluble vitamins, which are vitamins A, D, E, and K. A quick way to remember the fat-soluble vitamins is, remember, ADEC. So as we talk about absorption, it's important to think about, again, the fluid systems within the body and how that fluid travels, therefore how it transports nutrients to different sites amongst the body. In the vascular system, again, the water-soluble nutrients travel there, and they're absorbed from the GI tract into what we call the portal vein, and they travel first to the liver. From there, they travel to the heart and then travel out to all of the cells to provide nutrients as needed. Now, the lymphatic system, where we absorb those fat-soluble nutrients, the lymphatic system travels and sends those fat-soluble nutrients from the GI tract into what we call a lacteal, or a lymph vessel, into the thoracic duct, which then also dumps off at the liver. From the liver, it then is sent to the heart and then travels again throughout the body to provide nutrients. Now, as we take in nutrients, we need to keep in mind that sometimes we take in more than we might need at any individual setting. So when we have a meal, typically we're consuming more calories than we're going to burn in that particular setting. So our body has a nice, sophisticated system for storing that energy for later use. Our body's really designed to eat at intervals of about 4 to 6 hours, but keep in mind the cells still need those nutrients around the clock. Our three locations where we can store energy nutrients are the liver, muscles, and adipose tissue. So in the liver, we store extra energy as glycogen. It's a storage form of carbohydrate. So it's very, very similar in structure to carbohydrate. It's glucose units all bound together, but in a very branched-like structure, which keeps it compact and allows us to store a maximum amount of energy in that form. We typically can store about 3 to 6 hours worth of energy in this form, depending on whether we're an athlete and what kind of our history is as far as eating patterns. Muscles are another location for storing energy, and it can be stored again in the muscles as glycogen, but they're of a different nature. The glycogen that we store in our muscles is used only for muscles. They're kind of selfish in that way, whereas the liver, that will provide energy for the whole body as needed. Lastly, adipose tissue or fat tissue is the fat storage location that we have in our body, which again, excess energy, once liver glycogen stores are filled and muscle glycogen stores are filled, then we would start storing energy in the adipose tissue or fat cells. We have an infinite capacity to store fat, and the great thing about being able to store fat is that it will help us in times of famine when we don't have food available. Of course, we still need to be taking in water, but a person can last for days, weeks, or months living on the energy from their fat stores.